Okay, hello everyone. So I'm Matthias Krause. I'm a professor at ETH Zurich, also chair of the ETH AI Center. I'm co-founder of ETH of LatticeFlow. I'm super excited to welcome all of you on our AI safety session here at the AI House at Davos. AI safety is on everyone's minds, so it's no surprise that we already had a bunch of discussions around this topic here. However, one aspect that we haven't really touched much on yet, but is super important, is reliability challenges around AI, particularly in high-stakes applications, often involving physical systems in automotive, for example, self-driving cars, but also other use cases in this context, industrial automation, and other high-stakes applications, finance, medical domains, and so on. The reliability is really, really crucial, and we really have to work hard to drive failures of these systems close to zero as possible, which make or break AI's solution in these domains. This is hard because we all know that AI systems can really fail in unexpected ways. And so I'm very, very excited to have this fabulous set of panelists here in our roundtable today to share thoughts about this from various different angles, industry, standards regulation, audits, but also from research, to really explore this question around kind of AI safety, robustness, trustworthy AI in this context.
Right. From the industrial perspective, and this is sort of something I returned to the physical world, my PhD with in semiconductor, but I spent most of my career in the digital space. So when I joined Panasonic, there was a realization that companies in the industrial space have been working on safety, reliability forever, for 100 years. Those of us in the digital world sort of play with toys that are affecting people's lives, right? When Panasonic in automotive makes a mistake, people die. Right? When Google makes a mistake, you click a mobile ad. It's a strictly speaking. And so for industrial companies, AI is yet one more technology to understand, to manage, and to leverage to utilize. A lot of the systems and processes, for example, a company like Panasonic has something called Product Security Center, and it's not just security from the digital point of view, just security for customers and so on. And so this is being incorporated as processes into these things. So I think there's a lot of things that I have learned from sort of watching how that works. And then there's also the industrial people that are saying, well, these digital guys that are bringing this stuff in, how can we trust? How can we rely? How can we put this to our customers in such a way that it maintains the whole ethos that we've had before such 100 years?
Great, thank you so much. Really, let me look at that.
I totally sympathize with the challenges the industry is facing, and one way I would at least say to approach the problem is for us to improve it, we have to measure it so that we know where we go and how far we've gone in a certain direction. And that's essentially an effort we, and my team in particular, is looking at the moment to come up with measurement criteria that characterize the robustness of AI in autonomous driving, for instance, object detection, classification, and critical core tasks in autonomous driving, lane following, and all of that. And so we are looking for ways to use uncertainty estimation and characterize uncertainty estimation as it varies with respect to the vehicle speed, the conditions on the road, and the distance to the object. And so we're hoping to develop a measurement criteria that will then help people understand how to score their systems with respect to the ranges of acceptability or not acceptability, and help the industry in that way.
Thank you. Maybe wonderful.
Yeah, sure. So, one of the things that we see is exactly these kind of measures that quantify how reliable or safe a system is. They may be well understood for technical people or, people coming from academia, but a lot of times it's very hard to kind of translate that to a language which actual decision makers in the business world can relate to. And I think there's still a lot of work to be done in order to kind of allow for that decision makers can make decisions based on, let's say, standards where they feel comfortable in taking their sometimes very impactful decisions.
Great, wonderful.
Yeah, and maybe just to quickly add, one gap that we've seen in the industry is there is kind of the gap between getting things to work in the perfect scenario and then kind of thinking about the safety afterwards. And I think it's very important in the future to make sure that this kind of topics are incorporated from the beginning, from the start, not kind of as an afterthought after.
May I do a bit? Absolutely, yes, please.
when people ask me what I can use AI for, I always tell them two things. One is about stakes that we'll just talk about. So, if somebody's going to die, then you really have to be careful. But the other is also about outliers and edge cases. So the particular kind of AI that we have right now is not particularly good at edge cases. I'm talking about Gen AI. It works by having a lot of data, and hopefully what you're doing in is very close to those data. But if it turns out it's not, then the systems tend to fail. We saw that also with a lot of driverless car systems. So they work in many day-to-day circumstances.
Thank you so much for bringing up these edge cases. We'll definitely get back to that also maybe in the context of audits later. So, any other remarks on applications?
Maybe one use case that we work on from a certification perspective is related to the identity. So identify people via video identification. That is something that came up more recently in regulations that it is allowed, but there's a constant kind of challenge on whether it's secure enough and how the technology develops. And it remains secure enough, and how do we assess that it's conformant with the standards and the regulation?
Yes. Thank you so much. Anyone else? Yeah, there are others. Yep.
Maybe you were first.
Yeah, one thing I was a little bit curious about hearing from especially people in industry is, suppose you do have good measurements, right? You know how to properly assess risk, and you develop a system and measured it and found that there is some risk that you'd like to mitigate. One thing that's different about integrating and deploying AI than traditional software, where somebody would write it manually and sort of understand it, is it's not always clear how am I actually going to mitigate that? Right? There's sort of a touch point with what's actually known and what we know how to address, and what we require, especially in high-stakes situations, right? And it seems like there's a bit of a gap there. So I'd be curious if you might think more about that.
Yeah, I just wanted to compliment a little bit from my colleague from this list, because right now there's a lot of press coverage for the AI Act, and you read a lot of things. And just to clarify, of course, the United States and us in the European Union had different approaches on regulatory terms. But now I think we will cooperate much closer again, because in the AI Act, as many of you know, we have just general principles, and say also on cybersecurity, on what biases mean, how to mitigate biases, and so on. But basically, you do not find really mechanism how to mitigate or processes to install or whatsoever. Those things will be developed in standardization heads to contribute to share all those insights that you collected over the last years, and therefore, fill all those gaps and build up all those mechanisms that are needed to really complement the AI.
Great. Thank you so much. I think that's also a great transition maybe to the next block of topics, sort of around the role of standards regulation. There's lots happening, right? Regulation front and in the US, right? The AI Act, right? Other efforts around the world, right? So risk came up. That's, of course, in this domain essential, right? And I think a general principle in the AI Act is risk certification. We also brought this up, right? Considerations of risk. So I'm very curious about how you think about this in terms of classifying, right? How does one go generally about it, right? And so I'm curious to hear your perspectives and your complementing. To continue, Ren?
Yeah, maybe shortly. So okay. So that part also the same applies to what I just said. The high risk categories, for example, or the prohibitions in Article 5. We found language there that is still rather vague, let's say. It needs to be complemented with guidelines from the European Commission, but also, again, a lot of rulings from courts, but also the AI office, board, etc., needs to specify a lot of things. And there, again, we are heavily depending on the standards where those things will be specified, and then it will become clearer what is high risk. But right now, because how Annex 3 and Article 5 are written, I would say it remains, even for the legislators, often a bit difficult to say this AI system is in, this AI system is definitely out. One thing that my boss and I personally criticized all the time is indeed that Annex 3 and Article 5 were not going in such detail, but were rather broad and saying, for example, employment, AI technologies should be considered high risk, but not everything used in employment is high risk. And therefore, there are now some exceptions. If it's for safety, it's not high risk or whatsoever. But again, it's safety is still super broad. And all those things, all those details need to be found. And my hope is now that the policy level is a little bit out. It's not a heated emotional debate anymore. That's, I think, experts are now taking over a little bit. I think this is a good step because there it's really about details, use cases, and so on.
Great, thank you so much. So standards were brought up a few times, so we just follow up on that, right? And so I'm very curious to hear also from from this, right, the perspective to understand, Exos announced safety funds, given the mandate, the Safety Institute in the US, right, and address these challenges. So I'm very curious about your perspectives on the role of standards. So some very much emerging.
We believe the standards will play a critical role in mapping out the risks and offering suggestions for how they can mitigate it in ways that industry can use them and policymakers can use them as well to craft legislation around that. We obviously at NIST are not a regulatory institution, so I don't have first-hand experience in regulation. Our mission is to develop sound technical guidance that can feed into that and help the community of stakeholders. As you have seen, NIST released the AI framework early last year, and now we're building out resources around it. A couple of years ago, we issued a document on bias. Just recently, we issued a taxonomy of attacks and mitigations in machine learning to help the community of stakeholders understand what kind of problems they're facing when they're deploying specific classes of AI technology and different use cases, and understand some of the mitigations that they can apply there to minimize the risk, with the understanding that some of these mitigations are limited. Not some of them, but all of them are limited. So you cannot fall into a false sense of security. And that's the role where we're hoping academia will come in to close some of these theoretical gaps that have emerged recently, and see if we can put the technology in a sound place, because a lot of the focus so far has been really on putting out new functionality without not much thought about safety and security. And I think we're now at a point where, as the technology enters the business space, we're at a point where we have to provide really actionable advice or concrete advice for the industry, for the policymakers to understand where we're getting into and how best we can manage the risks there. By the way, to follow up on the standards developments, later today, NIST is going to host a first workshop on secure software development for large language models and their applications. So we already have a secure software development framework, but that was developed long before the AI technology came into focus. So now we're going to follow up and extend it to that. And I encourage everyone interested to register, actually not register, but just watch the video streaming later today at around, I think, 4 p.m. Eastern European time to see, what the community thinks about it and how NIST is then going to use this input to develop specific recommendations along this front.
Thank you so much. Yeah, absolutely.
One way of thinking about risks is in terms of particular occasions. So, do you have a misdiagnosis in the medical applications or what? But I think unique to machine learning and to generative AI, there's a kind of technical debt that's worth mentioning, which is if you have a system that's feeding a lot of day-to-day data and then the world changes, then your systems can have a lot of problems and it can be very hard to track them down. We talked about mitigation before. Mitigation in machine learning often consists of just collecting more data, and it can take a long time to do that. It can take a long time to retrain things. And so I think there's going to be a lot of accumulated technical debt that we may start to see in the next year or two. A lot of people in the room are nodding their heads. So I think it's important to realize there's the risk from the problem. There's also the risk from the kind of solution that we're taking right now. We train on a lot of data and hope that the world is stable, but maybe it isn't.
Great, thanks so much. So I'd also love to hear from our industry representatives, right? So it starts up and playing a super important role for many, many years, right? I'm curious about expectations for the newly emerging standards around AI safety in particular.
Yeah, I really agree with what Gary said about focusing on applications. But maybe I'll try to paraphrase a colleague of mine, Mike Olson. we're likely to live in a world. There's a Gary Marcus who, occasionally sends cranky messages back. But it's really true. I think what Gary talked about, which is look at how what are the applications. It's the same underlying technology, but if you just using that to play games, that's fine, But if you're using that to guide a plane to landing, then you got to put a lot of rigorous systems around it. So it's still very early days because, I used to be a professor, right? We used to teach students computer science. What's happening now is that there's emerging probabilistic systems that a lot of the computer science graduates don't know what the hell to do with, right? We're used to deterministic systems. It's very clear that over the next 5 years, you'll see that LLMs, as smart as they are, will be components in systems that are going to be deterministic. We won't live with the output of an LLM and say, can we trust it or not? It'll be in systems. Yes. So I really like what NIST has done, which is not come out and say, thou shalt do this, but NIST is say, this is the framework and this is how you should think about it. And I think that's the right thing at this time, right? And one key thing is, of course, going back to the sector application versus technology.
Thank you. We'll come back. A quick follow-up, otherwise we'll move on to the next topic around. It's welcome.
Let's do it there.
That's fine. Yeah. Also, thanks so much. So it's like, yeah.
So what really good is if that has come up with we need to take three recommendations of what techniques I hear you talk or such a returning or from students. So what we see how I think is fairly broad collection of best practices. But I mean what you get so what would we to products to use that help us to reduce work that we have to give to the statistical testing here. So anything that really helps us to organize the system a bit there without fail. Just
thank you so much for that perspective. Let's maybe move on to the next topic around audits, right? In particular, that is really an important role also to really to context of compliance, right? Really with these emerging standards around AI safety. And so I'm very curious to hear about kind of the role that AI audits will play in this context, but really about kind of checking compliance with these standards, but really helping also industry to be on firmer grounds with respect to compliance with these standards. Maybe, Matthias, you want to comment on that?
I think it's a good point, and I think the main thing we need to achieve with audits and with standards, yes, basically instill trust. Yes, if we do a survey, we did a recent survey, 66% said not really trusting AI. And as we move towards high-stake application, that will be way more important. So the standards should actually help doing that. And for me, the trust equation is pretty simple. We need safe, resilient, reliable infrastructure, plus we need a responsible use and transparency around it. Yeah. So that's what should be regulated. And then I just looked up on ISO, there are now 20 standards out, 10 international standards out, and maybe quite a difficult thing to actually implement them. And only if you implement them, they will be working. So with audits, we can first help the stakeholders, broad stakeholders, to get that trust, because you have ideally a third party or so coming in and looking at it and having a different perspective on it. But we can also set a level playing field. So otherwise you will have the issue that maybe people do forum shopping, so they go to places and are less regulated where the standards are lower. That's one thing. And also you basically incentivize those without unsafe applications, because you don't win your clients just by saying we are safe with the other if you cannot actually show that. And that's why it's so important to do those audits, to have the technology, to do thorough audits and not just kind of high-level fig leaves type of
Absolutely. Thank you so much for sharing these thoughts.
I'll say one obvious thing about audits. Okay. Like if you have a driverless car, you want to audit to make sure that it's actually doing everything it's supposed to do. I think generative AI, especially open-ended, some people call it general purpose AI, introduces a new set of auditing questions. we don't really know what the user is going to do with something. So a nav system in a car, we know basically what it's going to do. We know how to audit to make sure that it's doing correctly. But with generative AI, people ask systems essentially anything. Yeah. And there could be all kinds of weird uses that nobody anticipates. So one of the things I think we need to do actually is to audit the user logs, have some people with some competence to look and say, what crazy things might people be doing here, like medical things that it wasn't even designed to do.
Yeah. Such good
user logs, I think.
Very much agree. Sort of also approaches towards AI audits will depend very much on sort of use cases, and it might look very differently for auditing chatbots, right, compared to applications and automotive, for example. Maybe returning to those for now a little bit. You had a quick follow-up?
Yeah, I had a quick follow-up on the point of leveling the play fields in audits through standardization. And one other element in that is the various validation programs or certification programs that governments around the world have set up on variety of technologies. And the lessons, NIST certainly has had our own share of validation programs. So we're trying to channel the lessons learned there into this new arena around AI safety. And the primary lesson, I think, is to structure the problems in a way that makes them nimble. What you don't want to do is to burden the audit process with years of paperwork that will essentially yield a certificate long after the module, the technology that you certified is obsolete. And so these technologies we're dealing with are extremely complex. And so it's a big challenge to really define programs that can do it at real time.
So thank you so much. So and again, one of the key issues, like really with AI systems, is that they behave in rather unexpected ways. So edited multiple times, could fail in unexpected ways, right? And there's really interesting technical challenge around how to address that. So I'd be curious to hear from Pablo maybe a little bit about kind of experience there, and also the studies. You can comment on this.
Yeah, maybe just to quickly add on this one. So I think it's also important to kind of see where the need for assessments and regulations come in. And there is natural one that is this top-down coming from the governments to protect the consumers and clients and so on. But what we see, and I think this is the great thing, we also see the bottom-up adoption of companies who realize even without regulation, this is really the way to progress and how to make sure that we are actually building the systems in a way that we can manage and maintain the future. And the kind of main thing from the technical part, when we actually do these assessments now, it's not because we are doing it for the regulations. The main challenge we have is exactly this technological step, how we can, because it's a social technological problem. And with the current regulations, it kind of feels like social governance problem, and the technological part is kind of what we need to define as actually part of being able to do it, because you really need to go down to the level of the data and the model and the properties. Can you prove them or not?
Great. I think you wanted to.
Yeah, maybe just a short political point in my political message that I also wanted to bring forward today is that in the European Union, the AI Act is really, please understand this, only the first step. No? As I said already, a lot of other elements are necessary, and especially in this question, we have a big concern. First of all, one of the advantages in the AI Act is there's a presumption of conformity in Article 40 if you are designing your AI system based on technical harmonized standards. We discussed already. But no one really knows if Sensenelec, in cooperation with ISO, delivers those standards in time. And if not, then companies are a little bit in a tricky situation, because we discussed it already, auditing and testing and so on is not really harmonized so far, and especially since the AI Act has rather vague concepts often, companies will struggle for themselves to feel, okay, now I have enough legal certainty to invest in this product, bring it on the market, and so on. And our big fear is in this case that most, especially smaller companies, SMEs, startups, will need to hire, big four accounting firms, big law firms for a lot of money in order to get third-party auditing and certification. And this is, of course, something that the European Union did really want, because we wanted to strengthen our thing. So again, it's really important that the industry now is heavily engaging in standardization to have this element in place. And maybe just this very short comment to Gary, because third-party auditing or auditing per se, when it comes to foundation model, it was also one thing that we heavily discussed.
I think I wanted something very much in your direction. Unfortunately, we didn't get it in that way and the final text. But one of the key questions there, or key problems there, really, the AI office is now responsible for checking if the systemic foundation models, for example, OpenAI GPT-4, is fulfilling certain safety minimums, for example, and so on. But how do they do it? They need experts. Do they hire them externally? Where do they hire them? And there are not so many good experts. And again, the money problem, especially for the commission, there, I think academics will play a big role in this.
You want to comment from the perspective of startups?
Yeah, I mean, for us, we actually did an audit, and we actually we're talking about the bottom-up approach. So for us, it was important for our business partners to basically trust, the models themselves. So it's in order to increase adoption, you need to increase trust. And an unbiased third-party audit is crucial to basically establish that trust. So we don't really yet care about a regulation or standardization that much. For us, it was really like we lose money very wrong. So that's kind of it's in our interest to be as good as we can there. So it's really unique. But I think standards and also regulation will make it easier maybe in the future to, come to quicker decisions if something is good to go or not.
Yes. Yeah. Anyone else?
Can I build on just that?
A quick one, because certification was mentioned and also conformance. And I think it's good in the EUA you actually have a risk-based approach to it, because not everything deserves the same approach. And also there's things to learn from the aerospace industry, where certification essentially stick for innovation. And you have all those plates from the 50s, all those designed from the 50s still flying. So I think care has to be taken that the balance gets right between the debt for the high-stake applications versus allowing also startups and the young companies to actually develop, innovate, and move forward.
So we're getting closer to the end of the session. So we also wanted to talk a bit about opportunities for research. It was mentioned a few times already, right? But I'd love to hear the perspective on research here. Kind of what is the role that research can play in identifying efficiencies of current paradigms, but also offering new paths forward, the new architectures and so on. Maybe Matt, do you want to comment on that?
Yeah. I kind of wanted to jump a little on the audit.
Yeah.
Okay, sure. So I guess one concern that I would have, there are obvious benefits to standardizing auditing practices and group safety and security and so forth. But you can't lose sight of the fact that the science is moving very quickly underneath the deployments. And as we learn new issues and ways that things can go wrong, and how you think about mitigating, we have to be very careful with, especially standardized, where those fraud. Yes, that those are very far behind. So it's kind of easy for getting real expertise then. To provide valuable audit, not just an audit, then it's like instance part. Then we talked about mitigation as well. I think one thing that's a little bit unique about, especially generative AI and the language models, is the science isn't kind of deployment. Right? So we've identified problems that we simply don't have good solutions for. Right? There are things we could use, the edge a little bit. But we don't have, for some of those failure modes and some settings that you might think about deploying the large language model, for instance. There are problems that can crop up that we just don't have a good answer for. So I think it'll be very interesting over the next several years, especially as these technologies are deployed in systems that have some degree of autonomy and can, call on tools and retrieve data and make decisions. I think it'll be very interesting to see sort of how people balance fear of missing out with being responsible and
Alex, thanks a moment. I'd love to hear from you.
I'll see Matt's comment and raise one.
Okay.
I think that there's a set of problems that are unlikely to ever be solved by large language models. And they're never going to be grounded enough in facts. I think hallucination is going to continue to be a problem. They're never going to be good at planning. Or they're never going to be good at reasoning. They'll always be decent at them because they have a lot of human data to glom onto. But they're never, I think, going to be robust at them. So I think the biggest research question is actually, what is the next paradigm here? You know, I'm famous for getting in fights with young people or vice versa. But one thing that we actually agree on is we need a paradigm shift here. There are limits to large language models. My own candidate would be to try to find some kind of rapprochement between classical AI, symbolic AI, that's very good at OLIG representation, and neural networks, which are very good at learning. We don't really have a system that can take just a simple constraint like tell the truth, they'll make stuff up. Only pull facts out of Wikipedia and so forth that can't find it there, don't say it. And instead we have systems that say things like that I have a pet chicken in Henrietta that's completely made up. And I don't think the current architecture can solve that. So we need to dive deeper than we are. I mean, large language models are this shiny, gleaming thing that everybody's attracted to. I don't think it's the final answer to AI. I think it's the best thing we have right now, and we should be using it. And there's lots of commercial value in it, but we should be looking, what is the next thing too?
I have to.
Yes.
Okay, so there's not enough time to talk about the fundamentals of it, but completely agree. LLMs, if you want to use them the way people think, this is the intelligence that's going to control our systems. It's fundamentally, theoretically not possible. It's lacking long range intuitive planning and reasoning and so on. So one of the use cases we work on, think about this, right? Liquid natural gas with a company, Petronas, which is the national oil and gas company of Malaysia. So you talk about incentive. The use case is trying to reduce the turn up and down time. The number one cost of LNG plants is actually refrigeration. Because they just boil away, right? It takes, maybe I can't review the actual number, but it took an inordinate number of days just to travel on off and down. And they're trying to use technologies with us to try to reduce that by half. And that was something like $3 billion. They're not going to put it to control it. But what's missing is this next level. So one of the things you talk about research, one of the things we're researching is this this higher control, or the cognitive part, the control part, the executive function. But it's not going to come in down from within the LLM itself. Yeah. And that's why, I spoke earlier, it's like when Gary said that, people realize that LLMs are the components in a system. It is not the system.
You might want to share some. We have to wrap up very soon.
The research agenda, and to second the call for action to change the paradigm. The current paradigm is exhausted also from a security perspective. There are known theoretical results that show that no matter what kind of guardrails we try to put on them, their incomplete set guardrails can all be circumvented. And so here's an opportunity to call for the notion of information theoretic security in AI. We have that in other domains, cryptography, for instance, and where we can reduce the problem of security to implementation details. Here we have a much bigger issue, unsolvable issue. We have to worry about both the system itself and the implementation, which is really intractable. And that's a call for the academic community to really come up with different paradigm here.
Perfect. That's a mystic note to end.
Absolutely. Exactly. How to better end by a call for action, right? Yeah. So maybe let's just briefly wrap up. This has been such a fantastic discussion around this issue, just with the AI, reliable AI, and safety, especially in the context of finding critical applications. We've learned about exciting use cases where this really is make or break to get things to work. We've talked about the important roles of standard and regulation and how this can help sort of force this, kind of what technical approaches exist already. It's very much kind of emerging domain, and of course the important role of research in play and really driving with you for challenges. So I'd like to thank all of you so much for all these lively discussions. It was great to hear all of your perspectives, and I'd like to thank all of you remotely joining us for discussion. I'd like to thank you very much.
Thank you.
Thank you.